So for this video, we want to evaluate this integral here, 2 minus x, over the radical expression there. And of course, the first thing you always want to look at is what method can you apply to evaluate this integral. Obviously, partial fractions is out of the question. We don't have any rational expression there. Trig substitution could work. You'd have to do some, maybe completing the square under the radical. But I always look for a U-substitution, see if that works. Generally, that comes out to be the easier approach. So normally we let U equal to some expression under a radical in parentheses and see if we can get the derivative to appear somewhere in the numerator so we can make a variable change from x to u. So here I'm going to start with letting u equal to what's the radicand of this radical, 2x squared minus x plus 1. And then du would be the derivative of this expression here. So this will be derivative of 2x squared is 4x. Derivative of minus 8x is minus 8. Derivative of 1 is 0. This would be your dx here. And then it's nice if when you take this derivative, this expression right here is in the numerator. And at first glance you don't see it, but if you do a little bit of work here, factor out a 4 here, this would be an x minus 2. Not quite there, but notice I have a 2 minus x, and this is x minus 2. That's pretty close. Now the constant doesn't matter because you could always factor that constant outside the integral. So what I do here is I gotta do du over here. Let's divide both sides by 4 here, and then we can multiply by a negative. So this would cancel here. Multiply by a negative, and this would give me a plus 2 minus x. And the negative would be over here, multiply both sides. And this is dx. Sometimes you just take this expression and solve it for dx and then substitute what you get for ddx over here. But you can also do stuff like this. Got right there, that's 2x minus, or 2 minus x dx, and that's what I have right here, 2 minus x dx. So I can make that substitution for that. This would be the integral, and 2 minus x dx can be replaced by minus du over 4. This will be du over 4. It's a negative here, so let me just put the negative 1/4 on the front, and the denominator then that'd be the square. This right here is u, so this would just be the square root of u, and we're pretty much set now. This would be negative 1/4, and let's take this. This is the same thing as u to the 1/2. Square root of u is u to the 1/2. So if I take that up to the numerator, that would change the sign of the exponent to u to the negative 1/2. This would be du. Now it becomes a simple integration of this expression here with respect to u. So this will equal to, so the power root for integrals here, add 1 to the minus 1/2, and this will give me a 1/2. And then you divide the coefficient, negative 1/4, by 1/2, and then you have your constant of integration. And we're pretty much done now. So negative 1/2 divided by 1/2, and multiply, this will give me a minus 1/2. And that'll give me u to the 1/2, or I can write this as a square root, since that's what I started off with, a square root, but I could leave it with a 1/2 power. So it'd be square root of 2x squared minus 8x plus 1. And that's plus the constant of integration. So the answer again is negative 1/2 the square root times the square root of 2x squared minus 8x plus 1 plus the constant of integration. Thanks for watching. We'll see you next time.